Okay, we are live. Welcome. This is the TypeScript Berlin meetup number 3, and this is the first time we're actually going online. So we have some great speakers, and like to welcome you all. Our first talk is going to be by Henning Dieterichs, who's going to be talking about hacking the language service, implementing custom refactorings for TypeScript. So with no further delay, I'm going to bring Henning on board. Hey,
Hi.
Welcome, Henning.
Hi.
Are you ready to give your talk?
Yeah, sure.
Okay,
so
cool.
Thank you very much for joining my very first talk. I hope you are well in these crazy times, and I'm very happy to have this opportunity to share my knowledge about the TypeScript language service. But let me introduce myself real quick. So I would call myself an open source enthusiast. You can find all my work on GitHub. And I'm very much into programming language, Visual Studio Code, and developer experience in general. And currently, I'm doing my master's degree at the KIT in Karlsruhe. I'm also part-time employed at Knuddels, where I am responsible for the front-end architecture and the developer experience. So what will this talk be about? So hopefully, you will learn how to extend the TypeScript language service by implementing your own plugin. I will do this by doing some live coding where we implement the structure code action as such a TypeScript language service plugin. And in doing so, we will work with the AST and the type checker. So let's have a look at how the Visual Studio Code IDE interacts with the TypeScript language service. So Visual Studio Code has this UI, which is an Electron process and the extension host. And if you implement an extension for Visual Studio Code, it will be hosted inside this extension host. And there is this TypeScript extension that provides this TypeScript functionality like autocomplete, syntax, go to references, rename, and stuff like this. But this TypeScript extension inside Visual Studio Code only launches this TypeScript language service and communicates with it using the language service protocol. And this is really cool because this language service protocol is standardized, and other IDEs like Atom or Sublime Text can use this language service protocol too, so they don't have to redo all the work. So something like rename is implemented in this language service, and other IDEs can all use the same implementation. This is really great. Another cool thing is that we can extend this language service with custom plugins that are hosted inside this language service rather than just inside the extension host of Visual Studio Code. So if we would implement an extension inside Visual Studio Code, it will not work for other IDEs, but inside the language service, it will, which is really great. There are multiple ways to implement such a plugin. The easiest way is to just specify in the tsconfig.json. I'm sure you're all familiar with the tsconfig file, which is used to set up a TypeScript project. And another way is, if you don't want to mention your extension, your TypeScript language service plugin, you can just implement an extension for Visual Studio Code that activates the plugin for you. So this is the basic architecture. Let's have a look at what we are trying to implement. So this is some TypeScript code. I hope you are familiar with TypeScript. And our goal is to extend this language service to offer a code action. If I have this cursor positioned here, I want to be able to destructure this expression. So let's start with this x here. X is an object that has these properties x1 and x2. And I want to have my code action produce this code so that x gets destructured, which is often really useful. And in case of this merge expression, which merges the objects x and y has this property y1, I want to destructure all the members because merge has both members here. And the result should be like this. So the goal is to implement a code action that has been suggested with a lightbulb, like we can see it here, but this lightbulb will suggest other things. And I want to suggest destructure, and it will lead to something like this. Okay, how do we do this? We will start actually with a completely empty folder, and we will start with a package.json file. And inside this package.json file, we set the name of our plugin, which is something you can choose, like my TS plugin. And you define the entry point, which is in the dist folder. We will set up that soon. And we need to add TypeScript as a dev dependency. So we can have the types. And let's just install the dependency by calling yarn. And now we can set up a tsconfig file for our plugin so that we can use TypeScript to implement the plugin itself, tsconfig.json. And it is set up to compile to dist, to the dist folder, and it will include all files in the source folder. And also it enables experimental decorators, and it has strict null checks enabled. So let me create this source folder and this index file. So this is the basic structure. And I will now reload the tasks in the taskbar so that I have this watch task. And this will now transpile my source folder to this stuff. This should be pretty familiar. So this file then gets loaded by the language service, and it expects some structure here. So this is the basic template if you want to implement such a TypeScript plugin for the language service. Basically, it has a default export of an init function, and the TypeScript language service will then call this init function with the TypeScript API, and it expects this method to return an object that has a create function. And this create function gets the underlying language service, and you can return a new language service here. And this dummy implementation just returns the language service as is. So this is already a valid TypeScript plugin. How do we use this and how do we configure a project to use this plugin? If we configure it, we want to see something. And to see something, I implemented a pretty neat library. It's called EasyAttach. And with EasyAttach, you can attach to arbitrary Node.js processes that execute this line of code. And for some reason, I have to specify the debug pod to be pre-configured, but this is not important. So when the TypeScript language service loads this plugin, EasyAttach will allow us to debug this process. Otherwise, it would be really hard to debug the language service. So let's go back to our Visual Studio Code instance where we want to use this plugin. And we now go to the tsconfig file where we have this plugins section. And there we can mention our plugin. And this expects our plugin to be in the Node modules folder. Usually, if you want to deploy your plugin, you use like npm publish to host it, and then you can put it to the dev dependencies. But we don't, during development, we don't want to publish it every time on npm, so we use yarn link. With yarn link, I can just type yarn link in the plugin, and I can go back here and type yarn link my TS plugin, and it will create a symlink. So now I have my TypeScript plugin symlinked into this folder that where I want to use my plugin. So another thing that is really important, and you should not forget this, is you should select the workspace TypeScript version, and you should install TypeScript in your workspace so that the plugin gets loaded. This is for some security reason. But if you forget this, then your plugin will never get loaded. So now you can already see the plugin has been loaded and EasyAttach has been triggered. And if I switch back to the plugin, I can see here the debug node process button. If I click on it, Visual Studio Code will attach to this language service. And now we have this language. We are debugging basically our plugin that is hosted inside the language service. And this language service is used by Visual Studio Code to do various actions, like asking for which refactorings are available, how rename works, and all this stuff. And we can modify it here. We can actually decorate this language service by returning a new language service. And we can do this simply by using all the things that are already in the language service, and then we can override the stuff that we want to override. And to do this very easily, we just create a main class where we implement all our stuff. And in this main class, we will need this TypeScript object, this TypeScript API. So let me just declare it here, private read-only TypeScript, or let's call it TS, of type TS API. And it turns out, so we also need the underlying language service to do some stuff there when we implement our plugin or when we decorate it. So we have to inject this to our main class as well. Private read-only language service, which is of type, of course, just language service. Okay, that's it. And of course, I need to do type of TSAP here. This TS API is basically the local installed TypeScript API and has stuff like all the types and all the functions you expect if you just import TypeScript. But we shouldn't use this one. We should only use it for types because the TypeScript language service might use a newer version of TypeScript, newer version than what we installed with our plugin. So we should only use the TypeScript API that has been provided by the language service. But we have to use TS API for the types. So we are injecting the type of TS API, but we have to use TS. Now, if we want to implement a code action or refactor, these are the two methods we have to override: get applicable refactors and get edits for refactor. Get applicable refactors will list all the available refactors, and get edits will return the edits for it. So let's delegate these two functions to our main instance, like this. Main dot, I will copy this here. This. And we have to set up this main instance with the TypeScript API and the base language service. So these members don't exist yet, but I can use such a nice refactoring, which is hosted in the language service, to just declare these properties so that the types are all right. But also I have to bind this main because of JavaScript issues. And yeah, this should be pretty straightforward. We're just returning a new language service here that is basically the same as the existing language service. And these two methods we want to override. And in doing so, we allow access to the underlying language service. Let me convert these two properties to methods real quick, like this, and like this. So the first one, get applicable refactors, just is expecting an array, and we are on the safe side if we, for the beginning, just return an empty array. And here, we can also return undefined, and we can just return undefined to test it out. And we can just report a debugger statement here to see what happens, and restart the entire stuff and see whether it works. So we don't need this line anymore. And let's restart the language service here and see what happens. So if we restart the TypeScript language service here, easy attach is being triggered again. I can attach to the process again. And if I switch now back and, for example, click on the merge identifier, Visual Studio Code already asks our plugin to get the applicable refactors. And here we can now do our stuff, like we can return something. And here we can put some description. This is required, and I don't really know why. It's not being showed up anywhere. The more important thing is actions. Here we can list all the actions our plugin lists, our plugin supports, like the structure stuff and the name. So the description is something that is displayed for the user, and the name has to be unique. Like you can make it unique by prefixing it with your vendor ID. So like this. So if I now continue, it will still return the old empty array. So it will not reflect this change I just made. So I would have to restart the TypeScript language service again. This is not so cool because we are doing a lot of change, and restarting it every time is not so cool. This is why I came up with a library that I called Node Reload. I'm just installing this library, and Node Reload is basically what Webpack Hot Reload is doing for web apps for Node.js. So I just installed it, and I'm now importing some stuff from Node Reload, like enable Hot Reload, register update reconciler, and hot class. So enable Hot Reload just starts the file watcher that watches all JS files when they are being updated by the TypeScript watch service that's running in the background. And the entry module is just module. And with register update reconciler, I say that it's fine to just reload this entire module every time it changes. So the really cool thing now is the hot class attribute, because if I put this hot class attribute here like this, then every time I change a method, the method prototype is being updated, so it will always use the most recent body of this method. So in theory, this should be now the last time I need to restart the language service, because after then we can use hot reload. So restart TS server. Now easy attach should be triggered again. Okay, here it is. And now if we again let Visual Studio Code ask for applicable refactorings, like here, then we can see we undo the debugger statement, and I can just delete it and never be again there. And now everywhere I click, this light bulb is displayed, and it suggests to destructure something, which is not really useful because now I can basically destructure anything. This is definitely not what we want. And if I click on it, it even doesn't work. So we have to fix this. So if you look at get applicable refactors and get edits for refactor, you see that both have this file name and position or range. Here, file name and position or range. All the other options are not interesting for now. So it turns out both these stuff are doing something similar. So we can just introduce a new method that is called getRefactor that just returns either our refactoring with some information. We have to decide what information we put there, or just undefined if the refactor is not applicable at this position. And the arguments are just the file name and the position or range. So and the thing that we want to return is just the name for now of the refactor. So like this. And by default, we just return undefined here to, or maybe it's better to, by default, suggest to the structure. Sorry, the structure. So now we are wiring up. We are calling this getRefactor method that we just introduced for this file name and position or range, and call this R. And if R is not defined, we will just call into the language service that we injected already to this main class, to the underlying language service. And we ask the existing language service which refactors it thinks are applicable at this position. And here we have to pass all the position or ranges and all the other arguments. If we don't do this, we will basically disable all the existing refactors. So otherwise, we use this R to get this description, and yeah, we use the same for the name in this case. I think it's fine. Okay, let's put a debugger statement here and see whether hot reload works and it gets triggered. So I click on here, and yeah, hot reload works, it got triggered, and now we can implement this get refactor stuff. So for our goal, we need to work with the abstract syntax tree. But how do we get the abstract syntax tree? And it turns out the language service, the underlying language service that we already get, has a function that is called getProgram. And it returns a program. And we can ask, so basically a program is a TypeScript project or TypeScript compilation. And this has a function, getSourceFile, where you can put the file name, and then you get the abstract syntax tree of this file name, if it is included in the project. If not, it's returning null. But in this talk, we are going to assume it never returning null. So this is the source file then. And a really nice thing about hot reload is that if we are debugging a method and changing the method while we are inside of it, if we step outside of it, it will be restarted automatically. So if I press F5, it will automatically be rerun. But now with the latest change. So now I have my source file here, and I want to visualize this abstract syntax tree. And for this, I implemented an extension for Visual Studio Code that can visualize arbitrary stuff, but it has a special case for syntax trees, for TypeScript syntax trees. Now here you can see the entire syntax tree of SF. And here's the source. If you click on a node, then it will highlight this node in the source. This makes it really easy to implement refactorings. So the first thing we need to do is we want to find the node at the cursor. The cursor is basically this position. So basically, we want to find the node at this column. And this is quite easy. We need a function that gives us the node at a given position. This is basically the smallest node. And get node at position. And it has a parent and, TSADA. And it will return the node. And it also gets the position. So like this, position is the number. And here we implement the stuff. So basically, we are iterating over all children of the parent. And if this child contains position, then we are returning. So if the position is between cpos and AND, so we can't do it like this, we have to do it like this, then child is something that contains position, and we ask the same thing with C as the parent. Otherwise, we're just returning the parent itself, because no child apparently contains this position. So let's see whether this guy works. So const node at cursor is we get node at position of the source file as the topmost parent. And now we have to provide the position of the cursor. And we already have this position arrange, which can be, as the name says, a position arrange. So we have to deal with this. So if the type is a number, then it's the position, and we can just return the position. Otherwise, it's a range, and we just return the start of this range. So node at cursor now is the node at cursor. And if I press F5, it got reloaded. And now we can see whether it worked. And actually, the node at cursor here is now this identifier where we positioned our cursor. Some cool thing here is if I remove this debugger statement and just let it running and enable polling here, and for this I have to do something here, little hacky, node equals node at cursor. And if I now watch node, the global variable, and poll it, and if I click at something here, it will always point to the thing that we are doing. So this is quite fun to play with. So like here, we're clicking on the identifier here and jump to there. Okay. Let's go back here. Now we have the node at cursor. In case of the merge identifier, we want to identify, let me disable polling. We want to identify the parent expression statement. So we have, if we click on merge and this one has been selected, we want to go up until we find this expression statement here. So we need another function. Let's call it get parent expression statement, and it gets a node again of this abstract syntax tree, and it returns an expression statement, or undefined if this node does not have a parent expression statement. So if we can ask the TS API whether a node is an expression statement here. And if it is, we can just return node. And otherwise, if node has parent, then we can ask the parent to return it. And if it doesn't have something, then we just return undefined. So, and the parent expression statement then would be get parent expression statement of the node at the cursor. And this, of course, let's call it like this. Let's put the debugger statement here again and see what happens if I click on merge again. Okay, this thing also allows me to visualize multiple things at once. It doesn't. I think, wait, this is weird. Of course, I forgot this return. Easy bug. Okay, it works now, and we can see how node at cursor relates to it. So this is the node at cursor, this expression statement, and now we want to find all the properties that this expression has, and we can use the type checker for that. So the type checker is also offered by the program, and the type checker we can ask hey, type checker, give us the type for this node. And we are asking it for the node, for the expression of this expression statement. Now we have this type, and conveniently, this type has a function get properties. And we can just map all the properties to the name. And if you do it like this, you can now see props x1, x2, y1. This is for free. And now this part is better. So now we can do something like if props length is 0, then we don't want to suggest our refactoring at all. OK, so this part already works. So now the structure is suggested every time it makes sense. So for ZX, for example, it doesn't make sense because it doesn't have any properties, but here it does make sense. But if you invoke it, it will still fail. This is because we haven't implemented get edits for refactor. But this is very easy now. We can just call R again. And if not R, we should do something better than just returning undefined, like calling the underlying language service. But for Stark, we don't need to do this. And otherwise, it would be cool if R has information of this refactor edit info, so that we can do just like this, edit info. So let's just add edit info to our result here. Edit info, refactor edit info. OK, so we need to add the edit info here now, and everything will work. So basically, edit info is something that has some edits, and each edit that we can specify a file name, if we want to edit the current file name, and we can provide an array of text changes. And there we can replace a given span, and we don't want to replace anything. We want to insert it directly before this thing. So we are going to provide a span that starts where our parent expression statement starts. So like this, and the length will be 0 so that we don't replace anything. So basically here we can insert anything. And if I do it like this, it should already work because of hot reload. And if I do it like this, it will just insert this constant. This is not ultimately what we want, but the rest is easy now. So basically, I already collected the props. I can do something like new text. Basically, I want to have this object here and this here. This, and I want to suggest to insert the new text here. And here I can just use the properties I already have and join them separated with a comma. And this is it. If I now apply this refactoring, then it will destructure arbitrary expressions where the type system can figure out the type. Even if I do stuff like this, it will also consider this XYZ property, which is really cool. Yeah, now that we finished implementing our refactoring, do you have any questions?
We are now entering the Q&A phase. Let's see if any questions are coming in via the chat. And okay, so far we've had comments about if you can't follow, that's not because you're thinking too slow, that's because Henning is on fire. So Henning, thank you so much for the talk. And we have a question from Volker Braun. What's your favorite refactoring that VS Code doesn't come with?
I think it's inlining, because the inlining refactoring is super powerful, and you can reduce many other refactorings to this. Yeah, like renaming, like reordering parameters. You can do this with inlining.
Right. Okay. Well, on that note, we have the audience thanking you. Great demo. The rest is easy. So yeah, I'd like to thank you so much, Henning, for that insightful talk. And now I would like to, if you have any other things you want to say before we move on.
Yeah, one final thing. If you're interested in which tools I have used, like Visual Studio Code extensions, then you can find all the links on this slide. And thank you very much, too, for having me here.
Pleasure having you, Henning. Do you mind sharing the link with me so that I can post it in the YouTube channel, in the YouTube chat, to your slides?
Yeah.
So we will share that right after.
I can do this later. Yeah.
All right. Okay. Thank you, Henning. So we're now moving on to the next talk. So first of all, I'd like to mention that this meetup is organized by Contest and Prisma. We at Prisma just released the general availability version of Prisma Client, which is an auto-generated type-safe client in TypeScript for TypeScript and JavaScript. I highly recommend you check it out. And we also, if you're interested in learning more, we also have a conference coming up. It will be a virtual online conference called Prisma Day. You can go to prisma.io/day to check it out. So now we will move on to Emma's talk, who will be talking also about types runtime validations in TypeScript. So Emma, it's nice to have you on.
Hello, everybody. Thank you for having me here. It's a pleasure to be in this meetup. Besides, we are both in Berlin. We're doing remotely because of Corona, but still very happy to be here.
Great. You ready to give your talk?
Yeah. Can you see my screen and hear me well?
Okay. Yes.
Perfect. So then start. As I said before, hello, everybody. Pleasure to be here. The name of my talk is Runtime Types Validation in TypeScript. But first, let me introduce myself. Hello there, I'm Emanuel Suriano. I'm a web developer and open source enthusiast. I have some open source project there on GitHub, so you can check them. I'm also a tech writer, and also I have another non-tech blog, which is like I write about random stuff. For example, I've been writing lately about Corona situation. One of my hobbies is I'm a big fan of cooking, and also that involves eating and traveler. Yeah, big fan of that. As you can see here, this is a picture of myself when I was in Thailand, one of my best trips. And by the way, the food there is one of the best things I ever tried. So let's start with the talk. I've been working in this past around 2 years with TypeScript and different project size. And I just grouped up some of the quotes that I normally see coming up. This is the first one. My application is fully typed. It's 100% bug-free. Let's see. If it builds, it will work in production. That's a very good one. And the last one is we're using TypeScript. There's no need for test or to test. And I don't know about you guys, but my reaction is always like, why this is happening to me? Why people are reluctant, for example, of testing? Here's why. It's a very simple scenario. So this code is actually the build of TypeScript will pass, but we will see why it will actually explode in your face when you run it in production. So let's say that we have this example type here, which is a type with name, which is a required string, age is an optional number, and pets, there is a required array with name and legs. String and number both are required. Then we have this function, which is fetch data, just a promise that returns an object with this type. There is no need to code it, just we say that we're returning. Then we are fetching the data inside this function, which is getByte, who ideally will return the pets that has 2 legs. So what happens if our server returns this type of object? TypeScript will actually doesn't know what this will happen in production, so ideally it will build successfully. But in reality, once we execute this code right here, as pets is undefined and fine is not can be fine inside undefined, so this will explode. So yeah, I guess that many of the people in this meetup already know this, but TypeScript performs static type checking. Runtime validation are outside the scope. So it's actually on the developer side to make them. But then do I need to validate absolutely everything? So the question is no. As a general rule of thumb, I like to say that validate all the external sources of your application. What do I mean with that? For example, API responses, every time you have an API, it's always a good practice to type them to say what is my expected structure, but also validate the content, so you don't have the problem that I just showed to you before. The next one is content inside files. Let's say that you're reading from a file that you expect to have a specific JSON structure. So again, it's a good thing to type your structures, but also validate them, because it's quite easy to just change them, and then inside your code, everything will be fine in your build, but in runtime will fail. And the last thing is untyped libraries. So nowadays, if you're using some library that is well known, it will most probably come with a type definition. But sometimes, if we rely on some old libraries, they don't have them. We can type them. Also, is a good practice. But even though, like, if we are not 100% sure that the result will always be that type, we should at least validate them, just the core part. Okay. So let's see some of the commonly used approach to fix this problem. The first one, and is the one that most people go with, is the manual validation, which is a set of conditions that check if a structure is the expected one. So this is what it looks at manual validation. It's just a JavaScript file which will take our example type or expected example type, and then we'll basically check that bed exists. And then here you can do more checks in case you want to. And then basically, if everything is good, then you return true. Otherwise, you return false. Inside your main function, here's the same examples that showed before. We are just getting the data the same way, and then we are just calling the function with the validate. In case it doesn't work, then we can say validation error, property not found. And the thing with throwing an error here is that we can catch it and perform better approach or better error handling on the higher level. And at this point, we know that our data, at least given this validation that we wrote before, like, are compliant with my type. So some pros about this is, well, the first one is doesn't need any external library. This is just vanilla TypeScript or vanilla JavaScript. And the other thing is business focus. What I mean with that is basically you can check some properties that are by some reason inside the business logic link. For example, maybe property A shouldn't be present when property B is there or something like that. Given that it's a function and you can change them the way you like to, you can add this business logic inside. But the cons is, first of all, it's a manual work. Basically, they're handmade written functions, so you need to take care of that. And then the second one is that you're duplicating the code, because here you're saying that inside your example type, in your definition type, there is a pets array that is going to have name, and you're going to have legs. And here you're saying, okay, data has a pet. And actually here we are not even checking for name and legs in case we want to like do it really strict. So I would say the more you validate your structure, the more you're going to repeat yourself. So as we know, that's pretty bad. Then we go to the next approach, validation library. This is basically make use of existing validation libraries out there to check for the structure. So inside JavaScript, there's like many validation libraries. To just summarize them, or I just make a quick search on Google, what are the most used and the one I used in the past. The first one is AGB, Joy by Happy, V8N, and the last one is validate.js. In this example, I'm going to show one simple snippet of AGB. Sorry for turbulence, my God. In this case, we are just recording AGB, then we are creating an instance. In the case of AGB, it exposes a function that is called compile. Here, I'm going to define my schema that is going to represent my kind of TypeScript validations that I want to apply on. So in this case, I'm saying that name is a type string, which has to have a minimum length of 3. So this is one of the cool things about relying on a validation library. So normally they have helpers that will allow us to check more than if the property is there or not. And yeah, which is pretty handy. Then I'm saying that there is an age of type number, pets, which is an array with these items, like the items has this structure. And then on the last part, I'm saying, okay, name and pets are required properties. Then my main function will look like something like this. This is more or less the same. Data, wait, fetch data. This is going to return, as we saw before, this structure. And then we're going to call validate. This function, this compile function, obviously returns a function that we can send an object, and then it will check all these properties exist in the pass object. So if this validate function returns false, we're going to throw an error saying validation failed. And then as another advantage of relying on a library is that now we're going to be able to have formatted error messages or like better error management. So in this case, the validate function also contains the errors inside the object, and then we can format them. So this will be the message, the output message, error validation fail, data should have required property pets, which is pretty developer friendly, or at least it's not just a bunch of lines that you need to follow the code. And yeah, the same way, at this point, we are sure that our data belongs to the type that we assume that it is. So some pros and cons. The pros is it provides standardized ways to create validators and checks. What I mean with that is here we are saying, okay, this object has a name, and this name is a string, and then it also has a minimum length of 3. If you rely in the manual validation, there's several ways that you can do that in JavaScript or even in TypeScript. By relying on a library, there is only one way. And this is great when it comes to developer collaborations. And yeah, it's always good to have that. The second thing is improvements of error reporting, as I explained in the part of the snippet. Basically, you don't need to, in the previous example of manual validation, we were just returning false, which actually doesn't tell us why the object is not the same as what we're expecting. We can obviously improve it, but that involves more manual work. So in this case, error reporting is out of the box just by using the library. As a cons, well, it introduced a new syntax. I don't know what you think of, but this object syntax, I'm not a really big fan. That is a type was actually quite simple, and the amount of lines to define the schema was quite a lot. So yeah, and obviously introducing a new syntax inside the project requires more knowledge about it, and it increases the complexity. And then the other one is validator and types are not in sync. And what I mean is, let's say that in our example type, we decided that pets is not anymore required. It's just optional, right? So then I need to basically come here to this schema and remove the pets from here. And the same goes with any other property. And I decided to put here Starble specifically because there are some ways that you can generate the TypeScript types from your, in this case, HTTP validators. So the community built some tools around it, but still you have the cons of introducing the new syntax. So after seeing this example, let's see the approach that I want to show to you. It's called dynamic types validator. And the main idea is that you create validators from your types. And if you compare what we did before, or how it was before in the past two examples, we have the validator from one side, and then we have the types in another side. The validator obviously validates the objects, and then the types belong to the objects, or at least is what we are expecting to. And then in the end, when we both combine this, we're going to have a validated type object. as we saw in the previous cons, validator and type sometimes are like separated. They can be together. There are some workarounds that you can do, but most of the cases they are like isolated. In the approach that I want to show to you, the types are going to generate the validator. Then the validator is going to validate the object, and in the end result will be the same, which is going to be a validated type object. So I want to introduce to you a tool that I found. It's an open source library. It's called TypeScript JSON Validator. And the promise or the description of it is you can automatically generate a validator using JSON schema and AGV for any TypeScript type. And I want to give a huge shout out to Forbes Lindesai for building this tool. I didn't build it. I just found it out there. And I think it's amazing. More people should use it if in case you are using the TypeScript project. And let's see how it works. So let's say that we have our example type in this specific file path. So our type has a name with string, age optional with number, pets, which is an array with name and legs, string and number, and both required. So this tool is actually a CLI that you can call actually with npx if you want to. And then you need to specify two things. The first one is where, like which file this tool needs to look at. And then the second is the type that you want to create the validator from. So after you run it, this tool is going to generate a new file with the section .validator, and it's going to look something like this. So there is no need to go line by line because actually this file is generated automatically by the tool. But let's go just to the important highlights. So as the promise says before, this tool relates on AGV. So it's more or less quite similar to what we did in the library example. So here we are requiring AGV. Here we are creating the instance with some default values. Then, as you can see here, the type schema is being automatically generated for us, given what we have here. So this is very cool, which means that we can use TypeScript definition, and then they are converting into, in this case, AGV schemas, which save us a ton of time. And actually, if you take a look, this schema is better than the what I made by hand. So one difference is like I totally miss the required fields for items. I just said that legs and names are type, number, and type string. I didn't mention that they were required. So yeah, amazing that the schema is going to be automatically generated. And then the last thing is going to expose a validate function. So this validate function is something that similar that we did before. It's going to take a value with the type of known, which is actually more accurate than saying that it's example type. And then it's going to check, okay, is my value example type? And this function is here. And the only thing it's going to do is compile our schema. And then with the schema already compiled, it's going to pass the value. If this is true, it's going to return the value. And then this value is going to belong to the specific type, which is very nice. And then in case this throws like this is not true, it will automatically throw an error, more or less similar to what we were doing before, which is getting all the errors from the validate function. So yeah. And then how you use it? Actually, it's quite straightforward. You just need to import it because we are importing the export default function. And then we are calling the validate function given the input from the promise in this case. And there is no need to add an if, because if you look at the snippet, the if is already here. So actually the way that the code looks is, I would say it's cleaner. So yeah, next step. One of the cool things is about this tool is it's integrated with AGV. So you can create this kind of mix between TypeScript annotation and AGV properties. And it will not collapse between together, because as you can see here, this is the AGV annotations, and well, there are comments, so it's not going to interfere with TypeScript. And basically what you can do is say which properties will be taken care or consider inside the schema for AGV. So email, it's an optional string, right? Which is here. And then we can define that also we'll have this format of email. The same for answer. Answer is a type number, but also we are saying that the maximum number will be 100 and the minimum will be 0. So this saves a lot of time. And the only thing that we need to do is add this annotation. Now we are having a way better validation way of working. So wait for a second. This means that every time we run our program or application, we need to create these files again and again. And yeah, that's true. But if you think about it, well, we are kind of doing that with TypeScript. But by the way, in order to fix this problem, it's not that complicated. We just need to add a pre-build step. And in a very simple way, is that the pre-build step is one script that you add into your package.json or wherever you want to that needs to be executed before your application starts. So we are just calling TypeScript JSON validator with the same script that we saw before. So if we make sure that this script is always executed before our application starts, we can 100% say that this validator will be always be there. Another cool thing that I would like to recommend you, or that I think it's a better way of working, is that these validator files can be actually excluded from your project, from your git ignore, because they basically are being generated every time you execute them. And in case you change your types, they should be always like renovated. And yeah, in case you want to commit them, you can commit them. But in case you change your files, you're going to commit 2 files instead of 1. So yeah, it's up to you. But I recommend that to ignore them, and you will save a ton of file committing to your repo. Because the bigger your types are, this schema will be longer. So just take that into consideration. So my experience with this approach, I actually use this approach in one of my open source projects. The name is Gatsby Started LinkedIn Resume. So in summary, it's a tool that you can use to generate your resume in HTML and PDF format from your LinkedIn information and with Gatsby. So it uses these tools. So the first one is Gatsby in order to create a static website. Then JSON Resume, which is a tool that will take the data and then a template name, and with that generate an HTML and a PDF file. And then the last thing is LinkedIn, but I didn't use the LinkedIn Developers API because there is a lot of bureaucracy in order to get access to all your information. So I just decided to go for a, I would say, different approach and use a crawler. But the crawler, to be honest, does the job. So this is more or less in a nutshell what the flow does. So the application or the starter has 2 main commands. One is build and the other one is generate resume. So let's start with build. Once you start the build, you will ask the first question. Okay, is the resume data exist? If the resume data doesn't exist, you will need to jump into generate first your resume data, because obviously I can't generate your resume. If it exists, then we can easily generate HTML and PDF for you. Once we go to generate resume, we are going to make the same question. Is the LinkedIn data there in your local machine? So if it's not, then we're going to ask for the LinkedIn credentials. Then we're going to call the crawler. At this point, we're going to save this LinkedIn data in your file, in your local machine. And the main reason of that is because the crawler can take some time. And is actually, sometimes maybe you want to tweak your LinkedIn information a little bit. And it's handy to have a file there. After that, we're going to map it between the LinkedIn structure and the JSON resume structure, and then we're going to save it. So after saving it, you can go to build, and then you will be able to generate your resume. So remember that I said before what things should be validated, and I said external sources. So in this scenario, what are my external sources? So the first one is the data coming from the LinkedIn crawler. I can type my LinkedIn structure crawler response like the best way ever, but there is no guarantee that the crawler will always return that information. So I must validate it. And then the other one is the local file with the resume information. So when you look at this structure, there is no guarantee that here the guy actually didn't create a file and manually change the content of the resume of the JSON structure. So it is a good practice if I validate it. Like if you think about it, it's a file with the JSON structure that I need to validate in order to make it work with another tool. So yeah. And these are both the relevant types for these scenarios. So the first one is the LinkedIn schema. And in a nutshell, this is the structure of the crawler. Obviously, all these types belong to bigger structured data. There is no point to go into that. It's just to have an overview. And this is the JSON resume schema. And as you can see, it's different. It has some similarities. So for example, languages, here is optional, and here languages for some reason is required. It will always return a language. But one thing is this language, here is LinkedIn language, and here is JSON resume language. So that means that the types or the structure of the languages values are like differ. So let's go with the first scenario of crawler result validation. So this is the entry point of the right branch when we are like generating the resume data. So as you can see here, I'm importing my LinkedIn schema validator. These are some helpers, don't need to care about it. So this is the main entry. The first thing I'm asking if the file is there, is present. If it's not, then I'm asking for the credentials. This is just a CLI that will get me the username and then password. And then the second step, I'm sending the credentials to the crawler. This is the function that we'll call the crawler. And here I will get the LinkedIn data. Then I'm saving into a file. So at this point, I can read from the file that I just saved, and then I can validate it. So at this point, if for some reason the crawler returned invalid structure or a structure that I don't like expect, or the person manually changed the LinkedIn data, this will fail. Then at this point, I'm mapping, and then I'm saving. So here's another thing. There is no need to validate that here the JSON resume data is valid, because I did this mapping. I intentionally map it, and I know that my LinkedIn structure is valid, and therefore it shouldn't be a problem. So this is not considered an external source, for example. Then the other example is the resume content validation. And this happened in the file gatsbyconfig.js is the entry file for Gatsby when you can define your plugins. And yeah, more or less, what are you going to use in order to generate your website? So I'm starting just asking if, first of all, the resume JSON exists. If it doesn't, please run just the function of generate resume. And then after that, I'm requiring it and running the validation. And as you can see here, this is a catch. I'm importing my resume schema validator from the folder leave. And the main reason of that is Gatsby config, sadly, is a JavaScript file. Therefore, the validator was generated in TypeScript. So I had to add another pre-built script into my pre-build, which transpile the source folder and put it inside this leaf. So then I have access to the validation. But yeah, that's a little, just a little comment. And after that, I can send it to my JSON resume theme of Gatsby, where I send the JSON. And I'm 100% sure that it has a proper structure. So after that, I decided to create a table like comparing all the approaches that we just saw. So on the left side, we have the different approaches, manual, using a library, and dynamic types. So let's go column by column. The first one is no additional syntax. And in the manual approach, this is correct. It's just vanilla TypeScript, vanilla JavaScript. The second one, you need to know regarding, like, depending on the library you're going to use, how you create these validations. For dynamic type, it's actually pretty cool because what you're basically doing is just typing them. You're creating TypeScript definitions, and given that, you're having validations. So I will consider that as a check. Validators and types out of sync. In the manual, yeah, they're totally out of sync. You need to manually type if statements, asking for specific types. What is the worst thing ever is like what happens if you change your types. You need to go into your functions and change them manually. The good thing is the build step will fail, but still, it's a ton of work. For libraries, I decided to write down a question mark, and the reason of that is, yeah, there is some workarounds that you can make it work, and you can have them in sync. So that's why I decided to put a question mark. Dynamic types, as you are generating the validator from your types, they're always in sync. And especially if you run the pre-build script, like if you generate your validators every time you run your application, they will always be in sync. So that's a 100% yes. And the last thing is standardization. And I think this is a big one because in the manual approach, let's go with the approach of, I don't know, checking for the length of an array or the length of a string. For example, is an email. So there's like thousands of ways to check if an email is valid. When you decided to use a library, normally they say, okay, here's how you can check if the email is valid, right? And that's great. That's great because it avoids a lot of confusion, avoids a lot of bugs for sure. So yeah, that's not covering manual. You need to do it. You need to create your own standard inside your team. And then when you jump into a library, normally there is a way to do it. And this is very funny because dynamic types, given that they're using a library under the hood, they have this point cover. So yeah, overall, all these approaches, the one I really recommend of going through is dynamic types. So I just want to close with this phrase, which is validate more with doing less. Yeah, I thank you for listening. I hope you enjoyed the talk. And here you can find all the references that I use for the talk. And if there are any questions, I will be here to answer.
Thank you so much, Emma. That was really interesting, and it's a really novel approach where you validate more and write less. I think our audience will definitely have that in mind. We had one question at an earlier point during the stream where it was Volker Braun asked, is the syntax just normal JSON schema?
What do you mean by JSON schema?
I believe it was at the stage. There we go. Yeah. If we can go back a little bit.
This one or which one? The one that is generated?
Okay. I think. Okay. So Volker Braun just said he just had claps. So I'm assuming that we can resolve this after in the chat. You can feel free to hop on the chat. And we have also another one. Racelio Diak. Hi, thanks a lot for the talk, Mano.
Okay, you're welcome.
What about optional chaining defined in TypeScript to prevent undefined?
Yeah, you can do that. I mean, it's a way, but I don't think it will solve the problem of validating. Like optional chaining will allow you to just avoid your program from exploding. But eventually, there is one point that you need to add an if statement at any point of your in your program. So yeah, it's a way that I recommend this approach, because it's so annoying when you are working a TypeScript project and you are saying, okay, this object is of a type, but in runtime, when you go to the object and you check the value of the object, it's not. So I think that this gives like developers like security, that when you say that this is a specific type, it is really a specific type in runtime too, because I have previously validated. So yeah.
Thank you. And then we have another question. When using from Sublime Text, when using GraphQL, sometimes we don't return the whole object. Some properties will be missing in the case. The validator will throw an error, right? How to work around this?
Yeah. It's a tough question, because I also work with GraphQL and TypeScript, and it's a tricky situation. Like sometimes I realize that your types might be quite tight to the GraphQL schema, and I know that there is some ways that you can extract the type definition from your GraphQL server. And in this case, if you are saying that, for example, there is a property that can be optional, but then inside that property, the ID, for example, is required, that will work, because the initial property, let's say property A, is optional, which returns an object, right? But that object has an ID that is required, is going to be fine, because if your property A doesn't exist in the beginning, it won't check for the required ID.
Thank you for that. And we have, Emma, are you ready for one last question before we wrap up?
Yeah, sure.
Okay, so I don't know if you can see the screen. William Gomez is asking, do you think that a good PR for dynamic types would be to create a kind of migration system for validator generation?
Can you repeat that again, please?
Do you think that a good PR for dynamic types would be to create a kind of migration system for validator generation? I'm not so sure what he means here by a migration. I guess the question is migrating from what?
Yeah, exactly.
Okay, well, hopefully...
maybe if they're already using some kind of validation library, they can jump into this. I will say, for the people that I realize that this is a common problem in the front end, for example, that they're using just JavaScript tools, and like before they were using JavaScript to validate, and then they decided to move into TypeScript, and they have two different things running at the same time, and they need to maintain both things. So I will say, try this approach with just a few of them. The cool thing about this is you can run like some. Let's go here. You can generate the validators using this, and just generate the ones that you really want to, and that's it. Obviously, you can always create a script that go through all your types and create validators for all the types, but I don't think you have to do it. Normally, there's specific types that you want to create validator from. So yeah, I would say just give it a try, and also the cool thing is, like, you can see the code that is generated, right? So if you're used to this syntax, you can easily read it.
Right. Cool. Thank you so much, Emma. It was lovely having you.
Thank you.
And now we have Volker Braun. Volker Braun will be talking about Vue and TypeDI. So without further delay, I bring you Volker Braun. Nice having you here, Volker.
Thank you. Thank you for inviting me to talk, and thank you for organizing this whole thing. It's been great so far, and now I'll have to try to add my small contribution to it. So first of all, I'm Volker Braun. I'm also in Berlin. I don't know how many people are from Berlin on these online meetup, and how many people are from all over the world. In any case, if you're in Berlin, welcome. If you're on YouTube live on the other side of the globe. Great, welcome again. I didn't quite start with programming, but did a scientific career, and then only came pretty late to front-end development. I mostly did other more scientific computation. You might know me as the release manager of SageMath.org, an open source computer algebra system, but maybe not. In any case, that's not what I'm going to talk today. Today, I'm talking about my experience with TypeDI and Vue. Was really a project that I started fall of last year, hadn't used neither one of those, and it really turned out to work really well together. That was my experience, and I wanted to share that experience with you. It's not one of those things where after a month of work, you find out, oh, this sucked and I should have never done that. No, this was actually really nice. So let's jump in and let me tell you a bit about the problem that I set out to work on. So this is what we are doing is we are basically we provide software for conference organizers. So imagine you are a conference organizer and your first problem is always you need to get the data on your web page. You already have a web page. It's always WordPress or something horrible, but it's not something that you want to change. So what do? We want to write a plugin that you can put on your web page. We already have a management system for your conference data where you can have your data for your speakers and lectures and whatnot. But it needs to end up on your web page. And how do we do that? So first step is, of course, we need to get the data. So this will run in the browser in JavaScript and, of course, in TypeScript. And then we need to get the data. So we already have, since this is a front-end talk, we already have a backend API and everything. So what can you do? Well, you can pass it certain IDs, and it gives back data, JSON, nothing exciting. There's IDs for speakers and lectures and tons of other things. And because your conference isn't the only one that we have in our system, then you have an ID for your conference as well, which I'll sometimes call organization ID. And that's part of the API. And then there are queries where you're not coming with, I have an ID, but give me all of something with certain filters, and good. So that's the starting point. Then how do we make that into a program? Like there's of course the part that actually spits out HTML at the end, but that's not where I would start. I would start by thinking about how is my program going to be, like in big strokes, how is this going to work? So, and one thing that you probably always want to have if you want to have some caching is have some sort of data repository in your code, what I would call data repository, which just deals with loading data and keeping it. And if you need it again in some other place, then you can return the cached object if you have it, and or load it, and then at some point later it'll be there and you can return it. And all right, then the next step is, so you write all that. It's not particularly complicated. Then you'll find out, okay, I've got, of course, not just speakers, I've got lectures and whatnot, and I want to bunch those requests together. So there's only one API endpoint, so they all need to have talk to something that makes the API request and bunches them together. And then that thing needs to somehow do HTTP requests, but there's maybe at least 2 APIs that if I want, and I don't want to hard code it, so I'll put that into another layer of abstraction that I'll call HTTP connection. And then I end up with this. I have to wire things together. I make various steps of my business logic, and they all depend on other steps. So And at the end, then I have the interesting part, like I want to know what are the speakers of the lecture, for example. So I write, there's some object that figures that out, but it needs access to the cache of speakers and lectures, and that recursively needs other dependencies and so on. And it works, but it's not nice. So this is like the first step for, or the first pitch for dependency injection, where you can just automatically wire things together. You don't have to like manually go around and say, okay, I first make this dependency, then I plug it into this dependency, and then that. Now I'll just put in the add service handy decorator that I get from TypeDI, and then TypeDI figures out from the constructor what it needs. And if I have those also with add service decorated, then it automatically pulls things together, and you don't have to actually follow the chain of dependencies. And that would be my pitch. Like, if you want, why would I want to use dependency injection? That should always, I think, be the first pitch. It just does this automatic wiring, and you have to do it by hand. Nice. Maybe more formally, there's always some identifier for your dependency and the actual thing that it's being resolved with. That was not actually that visible, so let me just point it out. The type is the dependency identifier, and then conveniently, the resolution for the dependency is the instance of the type by default. Great. But you can override that for, and I'm not going to show examples for that, but that is then great for the usual ratio for why would you want to use dependency injection is, oh yeah, you can mock services in unit tests because you'll just inject a mock service instead of the actual service, and then you're not actually making HTTP requests in the unit test. But it's perhaps not that sexy a first pitch, so I'll just say this. It's one way of dealing with globalness. The dependency identifier, the type is global, and that's great because you only want to have one type. But the actual thing that it's being resolved with is not necessarily global. There's a default one that comes from an instance of type, but you can override it for various reasons. And then, okay, that was the first step. Now we have a repository that can pull the data, and we have a tool to tie together the repository and various business logics. And then it turns out there's actually quite an annoying amount of business logic, but that was actually fine. I mean, it's so what you have to do, you have to sort and filter when you filter lectures by keywords or by tags that you can give, all that. There's configuration. If you have a plugin on your web page, you probably want to change colors and paddings and fonts in some somewhat same way. So there needs to be some way to store the configuration for visual things and for what kinds of filters there are and so on. And once you have the configuration, put that in some sort of theming that uses the configuration data that's, again, stored in some service and turns it into the right things like CSS variables. And then there's time zones, perhaps not the last thing, because the backend, of course, shouldn't know about things like time zones. It should just store a time as a number, and then you render it, but suddenly everybody has a different idea of, do you want your local time zone or some specific time zone, or do you want to switch between different time zones on your web page? So time zone is actually, again, annoying and can also be nicely wrapped in some service. And that was actually quite a nice developer experience, just personally, I found that really nice. Also very nice, organize everything into services that inject everything as required and so on. Actually, time zones was a bit of a can of worms that JavaScript is not exactly good in the standard library with time zones. I use datefns, which is generally nice, except there's if you ever use it, watch out, the lowercase y and capital uppercase Y are two different things. And they're almost the same thing, except at the very beginning of the year. And well, shit happens, but we fixed that. Okay, fine. So this was so far, there's nothing to see, right? It's just the business logic. It does everything that you want, except showing it on the screen. So how do we show it on the screen? Of course, there's no shortage of frameworks. So I decided I'll use a framework that I hadn't used before, because why not? And because it's fun, and because Angular, what I would use otherwise, is perhaps a bit of a large machinery to just render a plugin on the web page. So I thought I'll give Vue.js a try, and I was also really happy with that. So I said you should be able to understand this talk without having seen Vue.js. So let me make good on that promise. Of course, like everything, there's components. You compose your UI from components. Components are in template controller style. You can paste all that into a single .vue file or separate files. I prefer separate files because I like my Emacs mode for HTML and TypeScript and the CSS, but it's whatever you prefer. Template synthesis is totally straightforward. It's like you've seen that a million of times, probably. Mustache interpolation, then the directives, and that's basically it. The directives are always v minus something, colon, and there's the two main ones are vbind, that binds a value, so passes it down to the component, and von is allows emitting something. So if something happens, then a method on my controller is being called. So here URL is some property. This just generates an image with that URL, and if somebody clicks on it, then the onClick method is being called. There's a shorthand that you just colon is vbind and add is von. So, and then that's basically it. There's if and v4 and for loops, but let's ignore those control structures. Let's go to TypeScript, and this is a TypeScript meetup, and you can actually write Vue.js components without TypeScript, but why would you? I mean, if you're obviously Braun here, just kidding. Now, you can use Vue.js without TypeScript, but I think it goes really well with TypeScript. So let me show you how I would enjoy actually writing controllers, which using this class-based components in Vue.js, which are optional, but pretty closely aligned with the core. So it's there, and it's one pretty official way of writing Vue.js components. And of course, there's add component tells you, of course, already, yeah, this is a component. Components, you may or may not use other components. If you use your components, then you have to declare your dependencies, so that later on you can figure out who uses what. And then what you can call your component, of course, whatever, extends Vue. And then basically the input is decorated with add prop. That means then that this is going to be defined by the attribute in the template that's using my component. And it's something that's being given to me. And then I can define whatever. So here in the previous slide, I used a binding for URL. So this is how would I define the URL for my image. And then if there's a binding to the click, then this is just a normal method that would be called. Pretty simple. There's no constructor, or the recommendation is not a user constructor. There's lifecycle hooks like created and mounted and so on, and a bunch of other lifecycle hooks. And you should be using this. This is more aligned with the view lifecycle of components. And there's not just construction and destruction. There's just more life cycles, no more lifecycle stages, and hence more lifecycle hooks. Use those. Is the official recommendation? Fine. Of course, that means that there's no constructor dependency injection into your component because there's no constructor, but that's fine. No big deal. We'll just use another way to pull something out of the dependence injection. All right. Just to quickly review what we did. Now we know everything about Vue.js. We made a component that's called speaker photo. We hand in our ID, which is here like a literal string, which of course it wouldn't be a literal string in production, but just as an example. And to complete the loop, of course, you also need a way to get events out of the component. So in addition to the add prop, there's an add emit for emitting things, and doesn't really do anything interesting except call a method on the parent. But that way you have data passing in with add prop and data signals being emitted with add emit. Great. Now, let's see if there's two kinds of, like as we saw in a previous talk, it's nice to riff again this runtime type checking with a static type checking. So how does it work here, or how can we take advantage here? On the static typing side, I can, well, every identifier is either a string or a number under the hood. I mean, what else can it be? But on the static type side, I can play tricks with branding. There's a couple of tricks how you could define brand, but either way you can define types that are stricter than just a string or a number. So you can't assign one type of identifier to a different type of identifier. But at runtime, this is of course removed by the TypeScript compiler, and at the runtime, there's only strings being passed around. So let's take this prop syntax apart. There is, first of all, required or not means it has to pass it. If it's not required, then it can be silently undefined because you don't pass it in. Perhaps tied to that on the static typing side is that I can declare it as either something that is my type or undefined, or I define that it has to be this specific type and can't be undefined. And of course, there's no constructor that TypeScript sees, so I have to tell TypeScript with the bang that yes, this actually can't be undefined, even so you don't see an initialization, because Vue.js is going to initialize that in its init somewhere. All right, and then there's a dynamic type check. That is, if you pass, you can tell the prop what the underlying JavaScript type is, because, well, this is string is the underlying JavaScript type. Then Vue.js will give you some error in the console if you accidentally pass in something that's not a string. But it, of course, doesn't know about the refined types that you have on the static typing side. So the refined types that, of course, you have to then declare yourself. But again, it's good to have maybe the riffing a little bit on Emma's talk. There's a static and runtime type checking kind of built in. And runtime type checking often come from, you mistype something in your template and you find them really easily because there's this runtime type checking. And static type checking is, of course, useful, as you all know. There's one pet peeve that I have that didn't quite work, or doesn't quite work as nicely as it should. So maybe we mention that. Maybe somebody has an idea for fixing it. If the type thing there has also a typing for what argument is being accepted, and that requires a constructor signature which excludes private constructors. If you haven't heard of private constructors, then it's really a handy trick to create objects where equality is actually equality. So, for example, by this, first of all, why is a private constructor? Private constructor, of course, means nobody can construct this object. That would be boring, except, and now comes the interesting part, static members can, of course, construct it because they're part of the object, and they can then enforce uniqueness, like just have a cache that you only hand out a unique object for a given set of arguments, and then equality is what you would think equality is. And nice, but that doesn't have a constructor signature because, well, its constructor isn't available to the outside world. So you have to do a somewhat unsightly cast. That's, anyway, just to mention this pet peeve. If you have any better solution, well, let me know. Either way, now we can put things together. We have all our business logic wired together with TypeDI, and that working nicely. And with Vue.js, we know how to give them some data, how to plus it on the screen, how to generate HTML. Now we just need to get our service injected into our component. And, well, the easiest, or maybe the most naive way is this container. There's the dependency injection container that you can import from TypeDI, and then container.get gives you the instance wired together of that class that you pass in. So here's the type. I've got my type of the speaker cache is my dependency injection ID. Container.get that gives me that object. Great. Maybe not too nice a syntax, but fine. There is a Vue TypeDI that turns that container.get into a decorator. Nice, but I didn't use because for the next reason that I'm gonna talk about. But before that, let me tell you a little bit about change detection, since this doesn't really have anything to do with TypeScript, but it is some of the underlying ratio for why this works pretty well together. So everybody has a little bit of a different riff on how change detection works. Vue, how does Vue do it? Well, it takes everything that's visible, that's like a property of the component, and recursively goes through it and all its properties and so on, and replaces all those properties recursively with getters. So, and the getters don't change anything, like they give you the actual value back. And if you set something, the getter just holds that value so you can get the actual value back. So this is replacing all actual properties with getters. Doesn't change the behavior of your code, but now Vue knows whenever you access a value, it knows when you read a value and it knows when you write a value. It just, as long as that value hangs off your component somehow. And then that's really nice with dependency injection, because you have to actually put everything inside your component anyways. That's how you want to use it. So what wouldn't work is if you have some global variables that lives in some other module, because then you can access that, but Vue doesn't know that Vue wouldn't have had a chance to replace those properties with getters. Only once you assign things into your component will this whole mechanism work. So it's kind of natural that you assign all your things to properties inside your controller, and dependency injection works great for that. That's the like half of how the change detection works. Now the other half is that the getters inside the component, which are called computed properties in Vue if you read the documentation. Now they are getting rendered, for example, with moustaches into your template. But then Vue, when it renders them, it evaluates them and sees where did it in your code, which thing did it have to look at to evaluate that interpolation. So, and then this is only ever recomputed if one of those inputs changed. So this is really nice that it automatically caches everything. It figures out what the dependencies are of your compute graph, and only if any of the dependencies changes, then only the things that are actually dependent on that are being reevaluated. And if that scares you, you can actually opt out with object freeze. So if you don't want your properties converted, then you can do that. All right. So this is why, but still, just to mention that this is why I think dependency injection and having things actually assigned inside your component worked really nicely with Vue. Okay, then of course this is great, but then the business requirements change, and now the next guy comes and says, okay, your plugin works great, but can we have the plugin 2 or 3 times on the same page, because I want my speakers there, and then I have lectures on one day and lectures on another day, and they're all on different places, and I just want to run the plugin a couple of times. And then that's of course, all right, now a challenge. What do we do? Okay, the easy part is Vue.js, you can just blow up multiple times. You want a Vue.js with multiple roots, great, no problem. But the perhaps problem is that some of the services hold application state. Like you want to actually remember what your filter was when you were filtering something, because then when you go back, you probably expect that you go back to the previous filter state and not to a completely new page and things like that. Okay, then fine. If you have one dependency injection container, why not have as many different dependency injection containers as you have plugins running on the same page? Actually, nice, perhaps lesser used feature of TypeDI, but works. Okay, but then if you now naively come, then everything gets like you want to load data only once. You want to have every plugin that's running in a different place on your page. Probably want to have different state, but not the entire state should be different. I would please have the same repository for each one of those. And that actually also works really nicely, because you can declare some service to be global. Oops. That means that in the dependency injection process, it'll only ever create one. For like you have multiple dependency injection containers, but they will always use the global one so in the global instance to resolve the dependency. And then you have normal services, quote unquote, that are just every container makes its own instance. And that actually works nicely. Now then, the final part of putting things together is how do we make a nice syntax? Now we know, of course, in our component. Now I want to have a service, so I need to first figure out which plugin am I running this in. There's a bunch of different places where I could be running. So you can ask Vue.js if there are multiple. If I've been if there are multiple Vue.js instances running on the same page, which one am I running in? And then you need to map those to different dependency injection containers and then pull out an instance from the right dependency injection container. And that's some, let's say, annoying, like putting your things into the innards of Vue.js, but it's not particularly difficult. You can do it. I was able to do it. It's perhaps unsightly, so I'm not showing you that. And you don't want to have some unsightly code every time you use the dependency injection. So now we want to take all this like convoluted details and wrap it into some as easy as possible syntax that I then use in Vue.js. And the solution that I had was write a Vue.js plugin. So what is a Vue.js plugin? Well, it's just a method that's added to every instance of a component. There's really not much more to it. And then we use the sophisticated technique of lying to make sure that TypeScript, like the language service, provides expansions for code that's actually not in Vue itself, but that's just some declaration file that you put somewhere. So TypeScript believes that there's a new method inject that's suddenly in every Vue instance. And then the final version of how this more complicated dependency injection works that I settled on was this. So there's just this inject. Sadly, I don't know how to turn it into a decorator, because decorators run at the definition time and not at the time where things are being constructed. So by the time the decorator runs, this hasn't been constructed, so it doesn't know in which plugin, if there are multiple plugins on the same page, the component lives. So we'll have to like make it into a method call, but fine, works. There we go. I can show you a quick page where this is actually running. If I can change the screen sharing to the next Chrome tab. Can you put me back on? Yeah, okay, great, thanks. So here's an example. There is speakers. You can click on stuff, then panels pop up. You probably believe me that the data was loaded successfully. There is we can look. Our Chrome tab sharing does not show the developer console. Wait. Let me show you the application window. Can you put me back on? Okay, so there's the developer console. And then for example, just as a debug aid, you can inject in the different services. This is not particularly complicated. We see that here's the actual service that's running in the program. Everything of interest has been replaced by getters, so we actually have to click on it since getters run code. So we have to click on it to see it. And then that's it. And the actual data class for my object, I'm using object freeze to opt out of this, because my models are immutable. Vue.js doesn't need to watch the name. The name can only change if the model changes. So there we are. This is basically was my talk. I just wanted to say there's one more tie-in with Emma's talk, because I'm also using JSON schema, and I didn't realize it before that this is what he was talking about. because the configuration is also some object that's held by some configuration service. That is the entire configuration, like colors and whatnot. And that object I'm also using is defined in TypeScript as a type. Then we generate a JSON schema out of that. And then there is a JSON editor on GitHub, JSON-editor.github.io, that lets you edit a JSON file that's defined by a JSON schema. So, and then was like a really nice hack to make an editor on a page that just edits the underlying data. And with the scheme defines what kind of fields you can edit. The JSON editor, which is a totally different project, makes then the different input fields, and then I can edit the color and change a different primary color and so on. So
Volker, sorry to cut you off. We're running a bit over time.
I'm finished. Sorry, this was.
Would you like to say any final words?
I think as the last speaker of the day, it's my duty to thank the organizers. So very many thank you for organizing this. And I've got a thing to try. How about everybody mashes the keys on the keyboard and write some random comments so we get get some life signs. So I'll start and.
So this is a good moment.
Let's see also what the delay is.
Okay.
Maybe you can pull up the other speakers too if they're still here. Then we can say.
Emanuel. Hi. So thank you so much, Henning. Thank you so much for preparing the talks and sort of sharing your knowledge and your experience with the TypeScript community. Volker, I believe you're in Berlin, is that right?
Correct, yes.
Cool. And Henning?
We're actually all in Berlin, or?
Henning is in Karlsruhe.
Oh.
So on behalf of Prisma and Contest, I'd really like to thank you all. Volker, if you want to share your slides,
I'll send
update the description on the YouTube event so that everyone can access the slides. Obviously, the videos will be available. We have some thank yous coming in from Slim and TN. If you have anything else before we go offline, this is your moment to ask questions, make remarks, improve, suggest different programming languages. Everything is okay. Okay, so
no different programming languages.
No. All right, so thank you all, and have a nice Thursday afternoon.
All right. See you guys.
Thank you.
Bye.
Thank you. See you. Bye.